All right, so when thinking about this stuff, one very important thing to keep in mind, and that often confuses students, but you just got to do some practice problems to really get it, is that a stronger acid has a weaker conjugate base and vice versa. The stronger your acid is, the weaker the conjugate base. The stronger your base is, the weaker the conjugate acid, right? And so we can see that in this chart as well. For example, sulfuric acid, very strong acid. If you put H2SO4 in a solution, chances are it's going to give a proton to something, right? But that means that its conjugate base is very weak. So HSO4 minus, if you put that in a solution, chances are it is not going to take an H plus from anything because it's so weak. And so when thinking about how strong an acid is, we often think of how stable the conjugate base is. Right? So, for example, if we have a reaction, right, generic HA acting as an acid, H plus, and to A minus, the more stable this A minus is, the more the right side is favored and the more acidic HA is. And we'll see plenty of examples of this. So, for example, if we have HCl, this is a very strong acid. Right, you learned in Gen Chem that this is a strong acid, and so it'll donate H plus and become Cl minus. And the reason that HCl is a strong acid is that this chloride is very stable. And it's stable because you have a negative charge on an electronegative atom. And so that's something that's very stable, right? And so that makes HCl very strong acid, but it also makes Cl minus a very weak base. So if you wanted to deprotonate something, take a proton away from something, adding chloride is a terrible idea because it's not going to work, right? And you can tell this has a pKa equal to -7, right? That's very strong acid. And so this right side is generally going to be favored. And HCl is a strong acid in water. So in Gen Chem, we drew it as a one-way arrow because in water it is. However, in organic chemistry, we do reactions in different solvents. And so it's not always a strong acid. It doesn't always fully dissociate. Let's take a look at another example. Here, we just have ethane, right? So we're taking a look at this hydrogen. And so in theory, you could rip off this H plus and put this negative charge on this carbon. And so here we have a negative charge on a not very electronegative atom, right? Carbon is not very electronegative, and so this is not stable, right? This is not stable, which means that this is a very weak acid. So if you wanted to have something act as an acid, throwing ethane in there would be a terrible idea. And you can tell its pKa is equal to 50, right? That's a huge number. And so it's very, very weak acid. However, if you wanted to have a base, if you wanted something to take away a proton, adding this guy right here, this carbanion, would be a good idea because this is a very strong base. And so by looking at one side of the equation, you can tell about the other because they're inversely proportional, right? A strong acid has a weak conjugate base. A strong base has a weak conjugate acid.